Alright, hello. So today we're going to be talking about syscalls, and I've decided that basically we will move the content, this content here for Lab 7, which says we need to install the Ubuntu kernel. We're going to move that to week 7, so we will have no lab this week. I don't know why it's not moving, but oh, there we go. So so syscalls. This will be good preparation for. This will be good preparation for next week. Preparation for next week. So this is from Panagotis, which is the professor that originally gave this talk. So the thing about a system call is you got to remember that basically we've got the user space, which is where the application is running, and the kernel. And the system calls exist between the application layer and the kernel. Kernel is there to sort of protect the OS and make sure that the system call has enough privilege to run. This allows it to run its drivers and everything it needs to run in kernel mode. So we talked about a couple times ago was the fork call. It's basically an almost identical clone of the parent that happens. It gets the program text, the stack, the registers, and the data segment. So what's happening is it forks it. It's going to be a PID of something less than 0 if it was unsuccessful, 0 if it's a child, greater than 0 would be the process ID of the child process that's been sent to the parent. Now exec, this is where we're going to get into a little more detail here. Exec actually replaces the current process with a new one. It's a family of calls. We have exec-L, exec-V, exec-LE. And this all refers to, as I mentioned before, this refers to what's passed as the arguments. Exec-L is the arguments list. V is the argument vector. E is some sort of environment vector, and P is the path. So it's all just about whatever exec is passed. Exec does not return to the caller. It fully replaces the process that's running. And then that appears in argv of the main function that's called. So typically what people do is they'll fork something and then they will exec it. Thanks. So here we see a example of forking and then execing. So the sh issues a fork. The fork code runs, spawns a new process. Then we do exec, and that overlays the process. So here you see an example of that. We also have wait, pause, and exit. These are utilities meant to control the flow of the program as it's running. forcing the parent essentially to suspend execution, wait for the child to die, and if there's no wait going on, that child becomes a zombie process. Wait PID also waits for a specific PID to finish. Here's a pause. So that's meant to suspend a process until some signal arrives. So we're going to talk about signals next. So a zombie process basically has no one waiting on it. Orphan is a parent that's finished. The actual parent finished and terminated, but the child is still running. And a daemon is just something running as a background process. There's a zombie process where parent spawns the child. Child process does an exit. Spawns another child, at which point that child becomes a zombie process as well. So signals. This is really the new content here today. A signal is an asynchronous event that's delivered to a process. Asynchronous means that can be sent at any time. Sending a signal to another process goes through the kernel, essentially. And the process can actually do a couple things with this. It can either ignore it, it can execute some kind of function in response to it, or it can carry out some default action for that signal. So as I said, the signal comes from kernel space, so it's sent from kernel to the application. Here's a signal sigint foo, and foo is a function that is being sent. So singer int basically means it can be interrupted. Kill is actually a command, for example, that's sent as a signal to a process to tell it to kill itself, basically. So pipes is another way of process communication. That means that we essentially direct the STD out of the first one to the STD in of the second. And we've showed pipes before, so like for example ls-l can be piped into grep key, which can be piped into more. Here's an example of doing a pipe and a fork. Now time. Time is essentially just a variable that you have in Unix, and you can call the time command to determine duration of any particular command. So we'll use this for performance testing. There's also a struct that can get you system time and user time. This is a clock. And then just some links. So that's about all I got for today. I'll be posting this online. Talk soon.